Continuous random variable x that can assume values between x is equal to 1 and x is equal to 6 has a density function given by fx is equal to 5. So this time we are dealing with a continuous probability function. So what they are saying is that fx is equal to 1 over 5 when x is between 1 and 6. And it doesn't matter whether you include 1 and 6 or not, since it's continuous, as we explained before. And what that means is that it's 0 otherwise. So at some point, we will stop writing the part where it's 0. Wherever we mention a density function, it would be understood at some point that it's 0 everywhere else. Okay, and you have to find the cumulative distribution function of this one, the capital F. And as we discussed in the cumulative distribution function for discrete variables, that it's a piecewise function, and the first piece always starts less than the part where its definition starts, where the definition of the probability function starts. So it's always 0 when x is, so if you're going by this, it'd be x less than equal to 1. But as I said, you can include the endpoints if you like, it doesn't matter. The way they have stated the big F, since they are starting it at x less than, so then we will just include the equal to here so that the first part starts at less than 1. Okay, so at x less than 1, it's 0. And then we also know that finally, when x is bigger than or equal to this last point where we have non-zero probability, then the whole accumulation is always 1. So you can automatically write that fx will be 1 when x is greater than or equal to 6. And now the question is that what happens between 1 and 6? Between 1 and 6. Okay. So here, what we have to do is, so we can even undo this last part, since we're not really using it from here. So we can say that when x is between 1 and 6, when x is between 1 and 6, f of x, so you start picking up the probability from 1. And x is you go somewhere between 1 and 6 to a value x. And the probability function there is 1/5. So basically, you go 1 to x, the little f of x. We can even write that step. We can say fx will be 1 to x, little f of x dx. And little f of x dx in this part is 1/5. And now you integrate. So the integral of 1 over 5 is x over 5. And the limits are 1 to x. And when you substitute x for x, you just get x over 5. And when you substitute 1, you get 1 over 5. So x over 5 minus 1 over 5. Okay, and they say use this to evaluate probability between 3 and 4.2. Now, you don't have to use this. You can just do this the way you're used to doing between 3 and 4. So all the interval between 3 and 4.2 lies between 1 and 6. It means this definition applies. So you would simply integrate probability x between 3 and 4.2 would be, but okay, let me just show you how you would do it using the big F. So what it would be is, it would be f of 4.2 minus big F of 3. That's how they want you to do it, although you could have just integrated from 3 to 4.2 the one-fifth function, as we did in earlier problems. So big F at 4.2 would be 4.2 over 5 minus 1 over 5, and then minus the big F at 3 will be 3 over 5 minus 1 over 5. So we are using this part of the big F, because that's what big F is when, as long as x is between 1 and 6, and both 4.2 and 3 are between 1 and 6. So for both these evaluations, we will use this middle definition. And f of 3 is 3 over 5 minus 1 over 5. And now if you evaluate all this, it should be 1.2 over 5, which is 0.24. Okay.